In this video, you will learn about the IUPAC nomenclature of haloalkanes, haloalkenes, and haloalkynes, the IUPAC nomenclature of alcohols, primary, secondary, and tertiary alcohols, and name cyclic hydrocarbons, that is, alicyclic and aromatic compounds. Haloalkanes, alkenes, and alkynes are compounds where at least one hydrogen in the hydrocarbon is substituted by a halogen. Halogens are fluorine, chlorine, bromine, and iodine. For example, a hydrogen in methane is substituted by a chlorine, and it is now a haloalkane. Or two of the hydrogens in ethene is substituted by two fluorine atoms, and therefore it is a haloalkene. To name haloalkanes, we follow similar set of rules as for naming alkanes. That is, identify the longest continuous carbon chain, which is the parent alkane. Then identify all the substituents, that is, methyl, ethyl, and halogens in the longest chain. The halogens are named as fluoro, chloro, bromo, and iodo. Then follow the lowest sum rule to assign positions of the substituents. Use prefixes di, tri, tetra, penta to indicate the number of each substituent. Name the substituents in alphabetical order. So bromo would come first, then chloro, then ethyl, fluoro, iodo, and methyl. So here's an example. The longest chain is a 6-carbon hexane. So the parent alkane is hexane. Then we identify the substituents, which are methyl, bromo, and chloro. And we place the substituent in front of hexane in alphabetical order. Then we use the lowest sum rule to assign positions to the substituents. And we can see that from left to right, the lowest sum rule is 10, so we follow that. And then we assign positions to the substituents, that is 3-bromo, 5-chloro, 2-methyl, hexane. In this example, the longest chain is a pentane. And we write pentane as the parent alkane. We identify the substituents, which is methyl, iodo, and 2-fluoro, that is difluoro. The lowest sum rule applies the same whether it's from left to right or right to left. So here the rule is the lowest position is given to the substituent which comes first in the alphabetical order. To name haloalkenes, the longest chain must include the double bond and give the lowest position to the double bond. So this compound is a 7-carbon heptene, and the lowest position will be given to the double bond, that is 1 heptene. And then we place the substituents, that is dibromo, chloro, and ethyl in alphabetical order and assign them positions. This is an example of an alkyne. So the parent alkane is a hexane with the triple bond on position 2, and the substituents are chloro and iodo. And the lowest position is given to the triple bond. To name alcohols, alcohols are homologous series that have a functional group called hydroxyl. Functional group is a group of atoms within an organic compound that readily undergoes chemical reactions. So in alcohols, the most reactive part of the compound is the hydroxyl group. The first member of the alcohol series is methanol. It is a one-carbon alcohol with a hydroxy group. To name it, the E in methane is replaced by OL. So this compound is methanol. Ethanol is the second member of the alcohol series. And again, the E of ethane is replaced by OL. In higher alcohols, the position of the hydroxy group can change along the carbon chain. The lowest number is given to the position of the alcohol group. For example, you have 1 propanol and 2 propanol. In this example, the OH group is on the third carbon, and therefore it is named as 3-pentanol, or you can also name it as pentan-3-ol. Here you'll see that the OH group is on the second carbon, and therefore this is 2-pentanol. In an alcohol with other substituents, such as methyl, ethyl, or halogens, the lowest position is assigned to the alcohol. So this compound is a 5-carbon alcohol, and there are substituents and the OH group along the chain. We give the lowest number to the OH group, so it is 2-pentanol, and then we put the substituents in alphabetical order and assign them numbers. So this is 4-bromo, 4-chloro, 3-methyl, 2-pentanol. When the hydroxy group is on a primary, secondary, or tertiary carbon, the alcohol is referred to as a primary, secondary, or tertiary alcohol. So in this compound, the OH group is on the primary carbon, therefore it's a primary alcohol, and it is 1-pentanol. In this example, the OH group is on a secondary carbon, so it is a secondary alcohol. And the name is 2-pentanol. And in this example, the alcohol group is on a tertiary carbon, and therefore it's a tertiary alcohol, and the name is 2-methyl-2-butanol. Here's how we name cyclic compounds. Carbocyclic or cyclic compounds are organic molecules in which carbon atoms are connected to form a ring. There are 2 types of cyclic compounds, alicyclic and aromatic. Alicyclic compounds are where 3 or more carbon atoms form a ringed structure. So here are some examples of cycloalkanes, alkenes, and alkynes. The first member of the cycloalkane series is a 3-carbon ring structure called cyclopropane. And these are the structural formulas of cyclopropane, and the formula is C3H6. The next member is cyclobutane. This is cyclopentane. And this compound is cyclohexane. Here are examples of cycloalkenes and cycloalkynes. This is an example of a 4-carbon ring structure with a double bond. And the formula is C4H6. And this is an example of cyclopentine, which is a 5-carbon ring structure with a triple bond. Then we have aromatic compounds. Aromatic compounds or arenes are organic compounds that have carbon and hydrogen atoms arranged in a ring structure with delocalized electrons. The simplest aromatic hydrocarbon is benzene. Benzene has 6 carbons arranged in a planar hexagonal structure with alternate single and double bonds between the carbon atoms. Each carbon atom forms a bond with a hydrogen. So the formula of benzene is C6H6. Now, the interesting thing about benzene is that the 6 electrons in the alternate double bonds are spread over the whole ring and are said to be delocalized. All the 6 CC bonds are neither single nor double bonds. It is somewhere in between the two. The delocalized electrons bring extra stability to the benzene ring. That means the benzene ring does not undergo chemical reaction easily. So in this workbook, you'll get to practice questions based on these concepts. So good luck and enjoy.